Hi, welcome to another episode of the power supply design tutorial. In this episode, we'll be tackling the current sensing and current limiting. I'm sorry it's been a while, but I've been busy with college and stuff, and I also had to take a break to build up the dummy load, which seems to work fine. And without it, I wouldn't have been able to do this properly. Basically this starts bringing things together now. It's one of the last bits of the analog section that we need to get round. And so without further ado, let's go straight to the bench and get started with that. Now, the first type of sensing we're going to look at is the Highside sensing, which involves putting the shunt resistor between the voltage source and the load. Now, what we're using here is basically 10 ohm resistors in parallel. Unfortunately, I couldn't find any 1 ohm resistors of this size. I've got a bunch of 0.1s and a bunch of 10s, but I didn't want to make a big bulky mass just for testing, so I did this. Okay, now we're going to use my dummy load, which I will eventually do a video on that, but that's going to be rebuilt eventually. But I was just thrown together for this specific subject. Okay, so what we're doing, we're using a 20 volt source from there, and let's just go make sure that's nice and stable still. Must be some kind of drift on there, because I actually set that to 20 volts exactly a minute ago, and now it's still getting to it, so it's probably still warming up. Okay, so yeah, these two go to my load, these go to the test meter. Now, the theory is simple. The current goes through here, it's a 1 ohm shunt, so using Ohm's law, 1 amp across 1 ohm equals a 1 volt drop. So we'll be measuring from here to here. We're basically measuring the voltage drop. So I will hook that up and we'll have a look. Right. This meter is showing the current flowing through here, and this is showing the voltage that's going across that resistor. So right now we're set at 4 milliamps. So as you can see, sorry, a bit of hiccups there. So let's slowly crank the current up and watch the voltage change in accordance. So let's go to, see if we can get to 200 milliamp. It's stable. Now, see, we have 200 milliamp, which equals round about 200 millivolts. As you can see, the relationship between that and that. So that's pretty good. Now, the numbers are going to be slightly off because the resistors are not high quality tolerant resistors, and my meters and stuff are not calibrated, so there will always be that. But that's how the Highside works. So say we didn't have this meter, all we had was this information. So we got, let's see, the 20 volts coming in, and we're reading 202 millivolts over the 1 ohm resistor equals 202 milliamps. I'm sorry, I should have been looking at that. So that's about it. Now, getting a bit warm, I'm sure. Now, the only downside with doing the Highside sensing is the common mode voltages here will be sitting at 20 volts. see right now, because I'm just measuring the difference now, if I put this down to ground, see we're measuring 20 volts at the top of the resistor, 19.7 at the bottom of the resistor. So the op amps have got to be able to handle that, or you have to put some voltage divider circuits in, which could lead to errors in your readings. Oop. So let's put that back if it wants to go in. Right. So yeah. Now the benefit of this is you're not interfering with the ground path, because the ground's going directly back to ground. And yeah, ignore that twitching. It's a bit of a software glitch with the averaging. I need to work on the software a bit more. Yeah, sorry. Yeah, you're not interrupting the ground path, which could cause problems in future if you were to interrupt the ground path. And plus, this also protects the transistor or whatever you're using from a direct short, so it'll make sure it's always loaded, even if it's like a little tiny bit. So okay then, so let's move on to the next bit, and then I'll come back again. Okay, so here we have the layout of low-side sensing. This time, instead of the resistor being here, it's actually here, and we're measuring across the resistor here in reference to ground rather than across. So we don't need any fancy differential setup like we would for that. So here it is now. The load is set exactly the same it was in the last example, and you see the voltage is it's 2 millivolts off, but that's 1.5 millivolts off. But like I said, that's due to the poor calibration and the lack of tolerances on the resistors or whatever. But for our purposes, it's pretty good. So as you can see, 202.5 millivolts over 1 ohm is 202.5 milliamps. Now the main benefit with this, like I mentioned before, we're only measuring this in respect to the ground, and therefore we won't be needing to worry about common mode voltages. Now, however, we are interrupting with the ground path. Now, since this is going to be in a power supply, there's going to be very little chance this load is going to short to the ground on here, because this is actually this ground is only relevant to inside the power supply. So as far as I can tell, that's the only issue with this. But I'm gonna go for this type of design for my system. Here we're back with the low side sensing circuit again. Now, as you can see 100 milliamp is roughly 100 millivolts, give or take a few volts due to the lack of calibration. Now you may be wondering, what can we do with this? Like, how can we use this sensing now we know it? Well, one thing we can do is we can stick this through a comparator circuit, and then we'll know if we're in our set limits. So what I'll do is this. Okay, so we'll draw the op amp, a little off center there. Okay, so this goes to the positive input. And basically, oh, no, wrong button, not button, wrong label. So here we can set the limit, and then this goes off to our voltage limiting circuit. That way, if the if the current sensed is higher than the set current we set, then it'll interfere with the voltage regulation and bring the voltage down, and that's what will cause the current to be limited. So I'll draw up a diagram and we'll have a look what it looks like in the grand scheme of things with the voltage regulation. Right, I've reconfigured the circuit. Now, this is the circuit that we're using right now. Made a little correction there. In actual fact, I didn't put that diode in yet, but we're not going to be in a situation where we need it right now. But for the final design, that's going to need to be in there. Okay, so we have the that's a dual op-amp package in place. This is the current limiting, and this is the voltage limiting. Right now, I've set the I got it wired in to that port showing you. This is the current limit I've set. Should be around about 500 milliamps for the setting, and at the moment it's currently reading back about 174, so it matches that. That's the live reading. Now, okay, so I'm gonna hook this up. So now we're showing the output voltage. Now, if I turn the load all the way down, see, I set the voltage to 10 volts. Now, unfortunately, I'm seeing a bit of a gradual change in the voltage when I get closer to the set current. See, right now we're at 4 milliamps. Actually, we should look at the top meter rather than the thing, because it's a bit more accurate. So I slowly turn up the load, and you can see the voltage slowly drops down. And it should start regulating at 0.5 amp. There you see, 465 milliamps. See, I keep turning the knob up, it doesn't go any further. And see, now I drop down below 465. It'll kick in a minute, there we go, and the voltage is now going back up. Now, I'm not really sure why the voltage is creeping down as I get closer to the limit. I'd really prefer it to not creep down as we go along. But I think that's because I'm using one of the op-amps. I'll show you on this side. I'm using this as a comparator, and I don't think it's working too well as a comparator. Or I may need some caps in there to filter. Maybe I'm not really sure. We'll have to experiment and have a play with that. So this is the circuit right now. I moved it all over. Some dodgy wires and stuff I had to work around. But yeah, the LM358 here, I'm using both sides of it. One for the voltage, one for the current. And these are the two transistors. And that goes off to the transistor over there. There's my current sense. There's my voltage sense. This is the basic layout of how the power supply will be in the end. I just have to iron out this little problem of the voltage going down as the load goes up. It's supposed to be regulated voltage, so it's supposed to keep it up. But it doesn't seem to be doing that too well. So okay, I'm going to put a few caps in there and see where it goes. Right, I've added 3 capacitors on here. I'll point them out. I added a nice electrolytic in the output, 47 microfarad. I didn't want it being too big, because that way the changes in voltage would be slow. So I put 47 on for now, and I put a couple of 100 nanofarad caps on the input of these transistors, and it seems to be a little bit more stable now. You can just see them in the center of the shot there next to the transistors. Okay, now the current limit pot is set to 401 milliamps. So let's take that out and stick it on to the power output. Okay, so I'm still set at around about 10 volts. Okay. And just turn it down. Now, see, we're basically no load. We can come up, and the voltage doesn't really drop very much now. So you get to around about 300-ish, and then it kind of falls off completely round about, come on, there, about just under 400 milliamps, which, if I go back to the settings, see, just about 10 to 14 milliamps below my limit, so there is some calibration and wiggle room in there that needs to be sorted out. But it's but yeah. Anyway, so that proves the current sensing and the current limiting. Nah, I hope that was enjoyable anyway. But this is the basic system I'm going to be transferring to a circuit board, and then we'll see about hooking these up to the DAC output on the Arduino. So that'll be coming soon. Well, I hope that was enjoyable for everyone. I certainly had a fun time doing it. But yeah, now we're one step closer to to being complete. Just have to do a little bit more with the software, but I think probably in the next video or two we can start putting it together. I will start building the regulation circuitry on that board where the Arduino plugs in, and we'll see about hooking up the DAC directly to this circuit, and we'll see where we go from then. I think it's come a long way, and we should be near the completion soon. So until next video, I'll see you then. Goodbye.